hi to everyone. This morning there was a series of talks focusing on text mining, which is essentially the key natural language processing technology that's being used in many different industries to extract information from unstructured text. So I'm going to speak to you about something which I hope will be complementary to what you saw this morning. I won't focus too much on the technology itself, although we will speak about it a bit, but mostly I want to show you applications in publishing. So my goal will be to illustrate this with a lot of examples of what our customers do with our product line and that technology, and hopefully to provide you a framework for thinking of how you might use the technology yourselves in your own projects. So it's not about product, it's really about use cases and value in the context of publishing. So I'm just going to put my timer on because it's going to help me stay on track, hopefully. So Themis was founded in the year 2000 by a group of ex-IBM researchers in natural language processing. They were joined a few years later by people from Xerox, just to illustrate that the company has been around in the field for many years, 12 years independently, and even before as part of larger groups. Our product is called Luxid. It's in its 6th version today. It's been recognized by several industry bodies as innovative, robust, one of the leading products out there. We're about 60 people in the company, and our main focus is semantic content enrichment. So I'll be telling you a bit more about that in a second. Publishing is one of our key verticals. We have, as you can see, a variety of different customer segments in publishing. So the top third, I would say, of the slide is really scientific publishing with some social sciences. Then you have legal, which is a big segment for us. Legal publishing might not be very familiar for you, but I would like to show you at least one use case coming from legal because they're doing very interesting stuff. B2B publishing focused on professionals, for example, in the energy sector, in construction, in automotive, and so on, as well as some customers in what you might call media or the press. So it's really an all-across technology which applies in many different segments in publishing, not only STM, even though I might be focusing a bit on STM applications today. In 2011, there was a really interesting study, a very thick document published by the Publishing Research Consortium. For this study, they focused on scientific journal publishers. So I think that's a population which is fairly close to the people who are present today. Maybe the exact share of respondents in that study is not exactly the one that we might find at the conference today, but nonetheless it's the same crowd. They asked these publishers, do you already use this technology? And we found it very striking that almost half of the respondents said yes, we use this in one shape or form. So this morning there was a question about what will trigger mainstream adoption of this technology. We believe that in certain pockets of the industry, and journal publishing and STM as an example, in fact we are already in mainstream adoption mode. Not to say that the entire industry has shifted, but a lot of publishers have already started using this, and we expect other publishers to adopt it increasingly. We think it's a technology that will generalize across segments in publishing. I haven't mentioned it yet, but we are a software vendor. So we sell software to publishers. Our software is also occasionally available through service providers. So if a publisher doesn't necessarily want to license it from us, it's accessible in service form from others if need be. I've been referring to semantic content enrichment as what we do. So let me show you what that really means. It's a series of steps really, and the first step deals with natural language processing, and it's really the only, let's say, technical slide in the entire slide deck. I want to show you that essentially we start with text. So this is a sentence which is actually extracted from an actual PubMed abstract. What we do is that we analyze this text first on the level of vocabulary, so terms. We recognize among the terms that are used certain objects of interest that our field calls entities. So in this case, we have a symptom, we have patient information, the name of a drug, dosage information, but it could be names of companies, names of products. It could be other concepts pertaining to your field, which have nothing to do with medicine or biology, obviously. So this is just one example. In this case, we're able to work through words, work through objects that are mentioned, and even through reasoning recognize relationships as they are mentioned in documents. So relationships between, in this case, some of the objects of interest, between a drug that's been administered and a symptom that's been observed in a patient. I think the key word to recognize on the slide here is role. So essentially, the side effect being hair loss, that's a symptom that could be a condition that you're trying to treat, or it could be a side effect of a drug being administered. So the notion of role really applies here. It's a very strong notion which essentially triggers the notion of relationship. Recognizing the role that these entities play in the relationship is key to understanding what's being said here. So the technology's role is really to provide intelligence into what is being said in documents, in sentences, and ultimately in large corpora of text. Once you've done that, the question is, what can you do with this? What, as a publisher, would you think of doing with this? So obviously, we've just spoken about analytics. Is definitely a major application. Extracting structured information in the form of claims that appear in these documents, that's also an application. But really, fundamentally speaking, all of this information that's extracted from text can be used to augment metadata. So metadata in the strictest sense is, name of author, date of publication, maybe journal, where the document appeared, but all of this information appearing in the document can act as essentially enriched metadata for the document. So all the objects of interest, in this case, symptoms, diseases, etc., appearing in the document provide a much deeper understanding of what's in the document without having to read it. And that's a key feature for publishing. One of the things that obviously this can be used for is to enrich any search function on any portal. So we'll be seeing examples of that. But also you can use this to trigger knowledge insertion. So if you have prior authoritative knowledge about any of these objects or claims, entities mentioned in this document, you can dynamically create links to that information. So one example might be actually an advertisement for a given product. That could be one type of link that you could create. But typically, for scientists, linking to structured information, in this case, for example, a page focusing on that drug, carbamazepine, that's mentioned in the document. As a scientist, maybe I might not remember what that drug is about. What are its properties, brand names, what are all sorts of information that you might find in DrugBank. DrugBank is obviously an open resource that you can find on the web, but it could be a commercial resource that you provide. Creating these links is a matter of course, once you recognize the objects mentioned in documents. So a further application, which is actually a generalization of the notion of creating this link to structured knowledge, is not only linking to structured knowledge, but linking to other documents. Presumably, it's not the only document mentioning the side effects of this drug. So if you find similar articles in your corpus, and this technology enables this to find these documents based on the concepts that appear in the documents, you can create widgets that recommend similar documents that will be relevant for the reader at the time of reading, because he was reading a document about that topic. This is a way of providing essentially automatically other documents focusing on the same topic. This strategy of linking really has no limit. You don't have to link on other articles regarding side effects of CBZ. You could link to articles that refer to other side effects of the same drug, articles that refer to other drugs inducing the same side effect, and the strategies can go on and on. Patents by the same authors, information about what are the mechanisms at play in hair loss, and frankly, the limits of the slide prevented me from going further, but I'm sure you could come up with other strategies. These strategies for recommending content that is going to be relevant for your audience is intimately linked to the type of content, but also the type of readers. So essentially, you would design these strategies as a function of who your audience is. These are a couple of ideas about what to do with the technology in terms of information access methods. So let's look at a implementation example at Nature. They have a feature in this portal, which is a highlighting tool where you can, by clicking here, it highlights in green. I know it's pretty maybe tough to see, but all proteins and genes are being highlighted in the document. So here, for example, we have SRSF1 being highlighted, and not everyone knows or remembers what SRSF1 is. So if you click on there, you get a little pop-up. These are actual screenshots, and you can see this, by the way, on the Nature website because this feature is open. You don't need a subscription to see this. What you see in the pop-up is a canonical name of that protein, a reference name, and then you see links to resources. So in this case, resources about proteins, UniProt being one of them, Entrez gene, and we'll look at another one afterwards. So if I click on one of those links, I get essentially linked out to, in this case, UniProt, and you have this a page focusing on that gene with all its properties. So what's happening here is that we're enhancing the reader's experience by providing information within the reading environment that was not in the original article. So we're really enhancing the reader's experience. Another example of linking at play here is a link towards Antibodypedia, which is a Nature product. It's a commercial product. It's not so much focused on knowledge about proteins, but rather on commercial availability of these things and where researchers can find them. So here you have a mechanism not to bridge people over to further content, but rather to bridge them over to sources of those products that they might be interested in. So it's, in a way, it's a lead generation mechanism, not unlike what we saw just a minute ago. Here's another example, in this case at Karger, a Swiss publisher focused on medical topics. Here we have related articles, recommendation widgets on the right of the screen here highlighted. Essentially, this performs the function I described earlier. You're reading an article about digestion. I won't go into the details here. If you want to know more, here are some other relevant articles on that topic found in the repository that Karger provides. Further example of recommendation at Springer. All of these are built on Lucid. Here, I would say a further kind of approach here is that they are not linking only to articles, but also to book chapters. So essentially, it's a platform which provides access to books, ebooks, as well as articles. So their approach here that the industry has referred to over the years as slice and dice, cutting content in smaller units, is definitely a key development in the industry, and metadata here is a key thing to enable you to describe the contents of each of those small units of content and provide links to those units in a relevant way for the end user. Okay, last example I think in this series at McGraw-Hill, this is in the energy sector. They provide for any article, these are news articles focused on energy topics. All of the topics extracted from the documents are clickable, so if you want to focus on Alberta or California, clicking there will link you to only content focusing on that area. If you're focused on hydropower, you can click there and that'll narrow down your search. They also provide suggestions to a wide range of different types of assets. Structured information about prices, related articles that are related to the original article you're looking at, related products, if any products are mentioned in the document, and charts as well. So this is pretty interesting because in their approach, they're linking to all sorts of assets, not only articles as in the original concept to a certain extent. So to summarize, in terms of information access for your audience, the benefits is really streamlining the search process, going faster to locate more relevant content, exploring content more easily thanks to these navigation features, and lastly, adding value to the original content, for example, by inserting knowledge, but also by creating links to further resources that your audience can explore. So ultimately, we tend to name this range of the use cases compelling content. And what's interesting is in the study I referred to earlier in the presentation, 82% of the respondents that are using the technology said, essentially, these are our categories, but essentially they map pretty well to what was said in the study. 82% said this is what we are using the technology for. And if you look at it commercially, it boils down to increasing usage. So for commercial publishers, increasing usage is obviously a key consideration. If it's subscription-based business, it leads to lower cost per download, and hence has a positive influence on customer retention when renewal decisions have to be taken. For transactional models, it leads to increased transactions, more pay-per-view requests, and even in open access focused communities, we see that this has an appeal. in the sense that providing mechanisms that promote content, that promote further usage of published content is something that appeals a lot to authors. And therefore, it is a way of establishing differentiation among authors. So if you want authors to prefer to publish with you, this set of approaches is a way of showing that you do everything that's in your power to essentially push their content. And increased usage, as we know, is definitely something that they are more and more interested in. There is a second range of applications that we tend to call semantic products. Again, it's our naming. I'll show you a few examples of these, but essentially, in many cases, they correspond to ways of serving smaller units of content that are highly relevant for a smaller population of users. And we'll see how that works. In the study I referred to, almost 60% of respondents said this is an area that we're interested in. From a business standpoint, this is new revenue streams, because these are non-existent products in many cases that you couldn't build easily before, but they're built with the same content as what you had previously, so to a certain extent this increases your return on assets as well. So here's an example at Nature. This is a topic page on the topic of interferon. As you can see, essentially it's a mashup of content coming from a variety of sources. Here you get, first of all, journal articles that come from all across Nature publications. So it's not one publication on the interferon, it's content that comes from a wide range of journals. Then it's links to job postings that refer to this topic, as well as discussion forums where the topic is being discussed. So hence the term mashup, aggregating content from a variety of different types of sources. Lastly, you might notice this area in blue up there with the names of PBL, interferon source. That's actually a sponsored ad. So they had a choice of how to monetize this, obviously. In this case, it's a sponsored product, so that brand is paying for this product to be essentially made available. It could have been an advertising model. It could have been a subscription model. In this case, it's a sponsored product. So with, let's say, automatic production of metadata, highly granular metadata, essentially building these pages is really comes at a very low incremental cost. And you can build thousands of these. So it's editorial automation. The overhead associated to each of these is very low. And essentially you can go down into very granular areas that focus on small populations of your customers. Here's another example. So in this case, a topical feed focusing on price trends in a given location for the energy sector. So again, if you're a subscriber, to this area of content or newsletter, you're going to get only content and information related to that topic. And that's again a way of slimming down the amount of information people have to deal with, which is definitely something audiences like today with the hypergrowth of content that we're seeing. And here's the last example. So this is a structured product. It's actually a knowledge base. So here we are in a situation where the publisher is a legal publisher, and they've extracted from case law, in other words, legal decisions, they've extracted structured information to characterize these legal decisions. And actually, you can see that all of these criteria have been extracted from text. So date of the decision, court where it was taken, age of the victim, gender, profession, etc., type of accident, disability, damages paid, etc. So essentially, for each legal decision, you have the description in structured form of what the decision was like. The goal of the product is to provide attorneys with a way of querying a knowledge base to find situations that are close to their customer's situation. So if somebody comes in, I had an accident in the workplace, I'm 35, I have 3 kids, what can I expect in terms of damages? Well, finding that information is very easy with this knowledge base. You get access to essentially, close to 500,000 legal decisions taken in France on the topic, and you can find related cases very easily. So again, streamlining the process of accessing relevant information. I'll skip the next two. They're just illustrations of other navigation mechanisms. And this is a bit more forward-looking. This deals with insertion of content and information in end-user workflows. So the scenario here is a scientist working on the description of a report of an experiment, and as they're typing in Microsoft Word, our software in the background is processing what they're typing, creating links to related documents that could be found in your repositories, in their repositories. Essentially, it's very open. related articles, schematics of related chemical structures, as those mentioned in the articles, in this report, as well as graph information, and really there's no limit. So this is more a vision of the future of what's possible. We're going towards integrating content and information into workflow tools and APIs residing on metadata-rich repositories will be a key for that. And there is a last, obviously, a third here of the pie, essentially, in yellow, which we believe 100% of our customers are benefiting from. It's productivity gains in editorial workflows. So one of the key workflows, obviously, is processing content to tag it as in some cases, a substitute for a manual tagging of the content as it sometimes occurs. So essentially that brings three benefits in terms of productivity that I've really tried to identify here with some of the cases that we've seen. So acceleration of content processing. So in the first example, for example, going from a 2,000 man-month process manually to a 5-month process, or in the bottom, essentially going from a weekly publication of consolidated legal text to a daily publication, so acceleration by a factor of 5, essentially. So acceleration is one metric. Another metric is the volume of content that you can process. So if you want to process more content with the same resources, at USDA, for example, we've enabled them to process 4 times more content than before with the same team as before. And lastly, reduction of the resources required. In some cases, we're able to almost fully automate, in certain cases, for example, extracting legal citations, reference to case law, for example, or legal texts, or anonymization of case law, removing names of people that are mentioned. These are almost automatic in some cases. So 3 metrics: acceleration, amount of content that can be processed in the back end of your workflows, and lastly, amount of resources that are required. To close, here are a few thoughts. We believe that this technology brings capabilities that are really aligned with your customers' expectations. They want to find relevant information faster and very simply. They're thinking Google. That's what they're expecting. To build easy findability and exploration features, you need granular metadata. They want to avoid too much information being served. You can serve more targeted content with this technology. So again, it's aligned with that expectation. And lastly, in some cases, they feel that why should they be paying so much for content which is available somewhere for free? So what that means is essentially that a lot of publishers are taking this as a suggestion to add value to raw content and value add, for example, through insight and perspective. And I tried to show you that through linking to other content and pieces of structured information, you can do just that. We believe it's going mainstream. We believe it helps publishers future-proof their business with 3 key areas of benefit: boosting engagement of the audience, leading to increased usage and retention, productivity gains in the back end, and lastly, product differentiation with new formats and new types of products. And I'd like to conclude just by saying that we also believe this is not a product feature, it's a platform. It's a platform both in the technical sense, that it goes in your back end, but it's also a platform for growth in the business sense. We see it as a way of developing your business in the near future and long in the future. So thank you for your attention.